So for 6.5 part 2, which is really kind of the start of 6.5, is the start of graphing. So we are going to be graphing what's called circular functions and looking at their features. So they call these things circular functions because we are going to come up with the graphs of the different trig functions based on the circle, right? Based on a whole circle of 360 degrees or 2 pi. And we call these circular functions, so sine, cosine, and so on, we call them, well, I should be called sine and cosine, really sinusoidal functions. They are sine-like functions. So that's what the word sinusoidal means. And the first thing before we start graphing them is just to sort of learn about some properties of different sinusoidal functions. So I've got up here a graph of a sinusoidal function. I'm not telling you the equation of it or anything like that. We just want to look at the different features. The first thing we want to look at is, does this graph have a max? Now for this graph, it will be an absolute max. Is there a point at which this graph can only go so high? So the max is the highest point on the graph. So we're looking at y values. So if you look at all of these little peaks, the highest all of them go is 2.5. And they all go up to this 2.5. So for the graph above, the max point is when y equals 2.5. Now this y equals 2.5 happens at multiple x values, but we just care of that the highest point is 2.5. So if the max is the highest point, then the min is the lowest point on the graph. And you'll notice that every single one of these has a trough way down here at negative 2.5. So the lowest point, or the min, is negative 2.5. All right, what else? Well, the next thing we're going to look at is a center line. It's a horizontal line through the center of the graph. So it's a line that makes the graph sort of symmetrical above and below. So if I was to draw a dotted line along this x-axis, you can see that the graph goes up a certain amount from there, and it goes down a certain amount from there. So y equals 0 is the center line of this graph. Now, one of the most important terms is this new term, which is amplitude. The amplitude of a graph is the absolute distance from the center line to either the max or min of your graph. In other words, it's how much it goes up or down from the center line. So if you look here, it's going up 2.5. And you look here, it's going down 2.5. But if we're looking at the size of the up or down, we don't talk about negatives. That's why it's the absolute distance. So the amplitude of this graph is 2.5. The next feature is the period. The period is the time for one cycle to occur. So you're looking for like a repeating pattern. So for me, I look at it happening where it starts on the center line, and then it goes up, and then it comes back down, and then it goes below, and then it comes back up to the center line. And then if you look, it would start that cycle again. It goes up, down, and then it would come back up. Even over here, right? There's that here, it goes up, it goes down, and it comes back up. So that's one cycle. So to figure out the period, you're looking at the x values over which it takes for this one cycle to appear or to occur. And so for me, it would start at 0, and it ends here at 6 pi. So the time for one cycle is going to be 6 pi. Now I chose that interval because it's the easiest, but I also want to point out that we didn't have to. I could have, if I wanted to, said that my cycle, instead of going from the center line up, what if it went from peak to peak? So if I, quickly erase that green, and I said, hey, what if I went from here to where it goes a peak again? So it would go down, and then it comes back up, and then it would go down and comes back up. And so if you look at that, this is halfway to 3 pi, so this would be 1.5 pi. And then the next peak happens at 7.5 pi. But you'll still see that the distance between 1.5 pi and 7.5 pi is 6 pi's. Okay, so no matter which 2 points you pick in your graph for that repeating cycle, it'll always be a distance of 6 pi away from each other. The next thing is the X-Intercepts. So X-Intercepts is where your graph crosses the x-axis. So if you look up here, you've got an x-intercept at 0, you've got another one at 3 pi, at 6 pi, at 9 pi, at negative 3 pi, at negative 6 pi, and negative 9 pi, and so on. This is only a snapshot of the entire graph. It keeps going on forever. So an x-intercept is where the graph crosses the x-axis. That's where your y value equals 0. And for this graph, we can see that they happen at negative 9 pi, negative 6 pi, negative 3 pi, 0, 3 pi, 6 pi, 9 pi, and so on. Could we come up with a general expression to show all of these x-intercepts without having to list them all? Well, they happen multiples of 3 pi. So the way to show that, and you'll just get used to this by the end of this lesson, is that you'd say 3 pi n, where n is an element of the integer system. In other words, if I put in n as 0, 3 pi times 0 is 0. There's that x-intercept. If I put in n as 1, 3 pi times 1 is 3 pi. There's that x-intercept. If I put in negative 2, 3 pi times negative 2 is negative 6 pi. There's that x-intercept. So this is a general expression to show all the x-intercepts for this sinusoidal function. The next thing is the y-intercepts. A y-intercept is where the graph crosses the y-axis. So if we go up here, what you'll notice is because this is a function, I can only pass through one y value, so you only ever get one y-intercept. So this graph has a y-intercept at 0, 0. So the y-intercept, I'm just going to say is 0, 0, or you could just say y equals 0. The domain is all the possible x values. Now a sinusoidal graph, there's nothing that you can't take the sign of, and this graph goes on and on in the negative direction as well as the positive direction. So the domain of this sinusoidal function is negative infinity to infinity. And then the range, well, is all the possible y values. It had a min at negative 2.5. It had a max at positive 2.5, so that's your range. Your range is anything between negative 2.5 and 2.5. All right, so those are all the basic features of a sinusoidal function. Now we're going to explore this with the 6 different sinusoidal functions.